Hello friends, this is my fifth lecture in Signal and System series. My name is Nishtha Verma. So in this lecture I'm going to take various numerical on the topic folding, shifting and scaling, which were asked in previous year gate papers or the questions which I have taken from different gate series. So in this question we have to plot xn multiplied by u2 minus n. So first of all we will try to plot u2 minus n first. We know that un you can plot like it is a unit step function, but in discrete time its magnitude will be 1 and the samples will go up to n. All the magnitudes are 1 and it is going up to n. So now we have to plot u2 minus n. So you can see that in this two operations are present. First is folding, then second is shifting. In folding operation we know that mirror image we have to take. So u minus n will become, all the samples will come towards left side. All the minus values, magnitude will be 1. Now we have to do u minus n plus 2. If you remember, when we were doing u minus n plus 2, all samples will shift towards right by plus 2. So now my signal of 2 minus n will look like minus 3. So here the sample, here the sample. It is going up to minus n. This is n. Now we have to multiply this equation by xn. We know that xn is given to you. How you are going to plot it? Xn, see here 0 position where the arrow is, then 1, 2, 3, 4 and minus 1. So at 0, 1 magnitude is there, 1, 2, 3, 4 and minus 1. So at 1 1 magnitude, at 2 1 magnitude, at 3 1 magnitude, and at 4 it is half, and as well as at minus 1 it is 1. So now if I will multiply this signal by this signal, multiplication property, we know that here all the samples are present, so we will take only those samples which are present in both. So the common samples are minus 1, 0, 1 and 2, because 3, 4 samples are present in xn but they are missing in u2 minus n. That's why my final value, suppose I am calling it yn, it will become at 1, at 2, at minus 1, all are 1 values. This will be my final answer. You can ask why the values are not present here, because we know that in multiplication if any number will be multiplied by 0, the answer will be 0. So here after minus 1, at minus 2 and minus 3, these 1 values are present in this signal, but the values are absent in this value, so it is assuming 0. So that's why we are not getting any value after -1. In the same way, after 2 we are not getting any values because those values are missing in this signal, but it is present over here. So this will be my final answer. Now second numerical. Here we have to plot xn minus 1 with delta n minus 3. It's very simple. Xn minus 1 is given to you. It means it is arrow is given over here, so 0 is here. 0, 1, 2, 3, 4, minus 1. If you plot it, this signal will look like xn 0, 1, 2, 3, 4, minus 1. So all the values are 1, up to 3, 1, 1, 1, 1, and at 4 its magnitude is 1 by 2. This is n. So actually we have to plot n minus 1. If you remember, in n minus 1 we used to put 0, n equal to 1. So it means we are going to add 1 in all the points, so it will shift towards right. All the samples will shift towards right. So my x n minus 2, n minus 1, sorry, will become, the minus 1 value will come at 0, 0 value will come at 1, 1 value it will come at 2. Like this every sample will shift, and so now my sample will be up to 5. So this is 1 value, this is 1 value, this is 1 value, 1, 1 and half. So now we have to plot delta n minus 3. We know that delta n look like, delta n means sample unit delta signal is sample present at 0 only. So if delta n minus 3 means we are shifting it at the right side, so delta n minus 3 will look like, delta n minus 3 will look like 0, 1, 2, 3. So at third position one sample will be present only, other value will be 0. This is minus n, this is plus n. So now we have to multiply this signal with this signal. So obviously multiplication will be present at the value, at the position of 3 only, because other values are 0 in case of delta n minus 3. So our final result will be only 0, 1, 2, sorry, 1, 2, 3. So only one sample will be present in final answer, and its magnitude will be 1. This is yn. Yn means output. This is n, this is minus n. Now this was a plot method. Next method we can use, if you remember the sampling method. Sampling property is del xn multiplied by this. So if my numerical is xn minus 1, xn minus 1 into delta n minus 3, so the output will come xn naught, means in place of n we are going to place n naught. N naught is over here is 3, so it will become x 3 minus 1 into delta n minus 3. So it will become x2 and delta n minus 3. So if we see at x2 the sample value 1 is present, So 1 multiplied by delta n minus 3. Delta n minus 3 we have already seen how it looked like, n minus 3. So at 1 position, at 3 position, 1 value is present only, other samples are 0. So it will be 1 sample. So it will be multiplied by 1. So our final result will look like this, and the equation will be this one only. Now next question is based on continuous time signal, and we have to plot x1 minus t. If you remember, this signal is consist of two operations. First is folding operation and second is shifting. So it is xt, so our x minus t will look like the mirror image. In case of mirror image, we have to be very careful while plotting mirror image. This will come minus 1, this is minus 2, minus 3. So the magnitude is 1 and 2. So this value will look like, it will be like this. So it will go straight, and straight it is going up to minus 1, and it will touch minus 3. So this is my x minus t. So after folding operation, shifting operation, if you remember, if I have to add in minus t plus 1, the signal is going to shift towards right by 1 position. So if it is going to shift right at 1 position, so obviously 1 plus 1 will be 2. All the sample value will be added by 1. So my final result will look like this. This is x1 minus t. So 1 become 2, then 1, 0, minus 1, minus 2, minus 3. So here it will come, then magnitude will be 1. So from here it is going to start, it will go straight down and it will touch minus 2, and here at the negative side the magnitude will be minus 1. Here it is 2. So in this way my final signal will look like. Now next is, we have to multiply xt multiplied by delta t minus 3 by 2. Here we have two methods. Either we use a plotting method, or second method is directly using sampling property. If you remember the sampling property, the xt delta t minus t naught result is equal to x t naught delta t minus t naught. So here x t naught, here t naught is nothing but 3 by 2. So x t naught means x t naught will be present over here, and its magnitude will be 2 multiplied by, sorry, this is multiplication, multiplied by t minus 3 by 2. So if you will plot this equation, we will get this is yt will be 0, 1, 2, 3. Between 1 and 2 there will be only one sample, its magnitude will be 2, and this is my final answer. Now next numerical is xn values are given, and we have to multiply xn by this equation. So first of all, I will plot this equation, then I will multiply it by xn. So if you remember, un look like unit step signal. It is discrete one, so sample values will be present up to n number. All the magnitudes will be 1. But here we have to plot un plus 2. If you remember, n plus 2, if you place equal to 0, so n will be equal to minus 2. So we have to subtract minus 2 from each sample. So now the final equation will un plus 2 will look like, it will start from minus 2 now, minus 1, minus 2, and here it will go up to n. The sample will be starting from minus 2. Now next is minus un. Minus un obviously will be in the negative direction. In the negative direction, all the samples will be having minus 1 magnitude. Minus 1, minus 1, minus 1, minus 1, minus 1, up to n. So now if we will add these two signals, we can see that the samples, because from 0 to up to n, 0 to n, all the sample value are 1. And here from 0 to 0, 1, 2, 3, 4, 0 to up to n, all values are minus 1. So when we will add it, these values will get cancelled, but only two samples will be present. So my equation for n plus 2 minus un will be having only two samples. That too, the sample will be present at minus 1 and minus 2 only, which magnitude is 1. And we know that xn, if we will plot xn, so 0, 1, 2, 3, minus 1, minus 2, minus 3. So it is 1 value, 2 value, 3 value. This is minus 1, minus 2, minus 3. So this is minus 3. So if you will plot it at 0, 0 sample is there. At 1, 1 magnitude. At 2, 2 magnitude. At 3, 3 magnitude. At minus 1, again 1 magnitude. At 2, minus 2, again 2 magnitude. Minus 3, again 3 magnitude. If I will multiply this equation by this equation, so it means the sample will be present only at minus 1 and minus 2, because minus 1 and minus 2 are only the places where samples are present in both cases. So my final result will be yn minus 1, minus 2. At minus 1, the magnitude is 1 and 1 over here. So magnitude will be 1. And at minus 2, the magnitude is 2 into 1 will be 2 only. So this will be my final result. Now next numerical is we have to multiply xn with delta n minus 1. So delta n minus 1 is very simple. We know that how delta n minus 1 will look like. Delta n minus 1, for delta n minus 1, the only one sample will be present, that too at 1 only. It's, if it is unit impulse, it will, magnitude will be 1. So it is going to up to n. And if we multiply with xn, so xn is 0, 1, 2, 3, minus 1, minus 2, minus 3. So at 1 it is 1 magnitude, at 2 it is 2 magnitude, at 3 it is 3 magnitude. Again at minus 1 it is 1 magnitude, at minus 2, 2 magnitude, minus 3 it's 3 magnitude. If we multiply these two signals, we will find that in final answer the sample will be present at one position only, because that is the only position where the sample is present in both cases. So it is 1, 1. So 1 into 1 will be 1. So this is my final yn. This equation we can do using sampling theorem also. In sampling theorem it will become, because xn into delta n minus 1 is there, so we know that xn delta n minus 1 result will be equal to n naught, x n naught means 1 multiplied by delta n minus 1. So at xn the sample is 1 only, 1 multiplied by delta n minus 1. So the plot will be this one only. So whatever the method we will use, the plot will be same, the output will be same. So in next lecture I'm going to cover classification of signal. Classification of signal will be, first will be deterministic signal and non-deterministic signal, and second will be periodic and non-periodic signal. Thank you.